Rohit is an independent consultant and trainer with over 10 years of experience in the environment sector. He is interested in geospatial applications for environmental conservation, impact assessment, and biodiversity mapping. He is well versed in geospatial platforms like QGIS, ArcGIS, and Google Earth Engine, and conducted training on forest change detection, geospatial application for landscape architecture, and species distribution modeling. He has extensive experience in environmental impact assessments, biodiversity surveys, environment and social due diligences for infrastructure projects. Rohit is also a published documentary and wildlife photographer and mm, been a part of various studies on habitat mapping of bats, documenting corals, mapping invasive species, and documenting ephemeral monsoon flora. Spatialecologist.org is a collaborative platform for research and consulting in the environmental domain that specializes in creating tools and frameworks for improving knowledge and sensitivity towards ecological issues. It focuses on using open source geospatial and other analytical tools for assessment and reporting of environmental conditions, also providing training for capacity building. We welcome you, Rohit Pansare. You can start with your presentation.
So I'm an environmental planner and a documentary photographer. So I have but here I'm going to talk about GIS and remote sensing. So it's kind of a weird combination. But let me, in spite of the introduction, let me just take you through some part of the journey that I've been on to make you understand how I reached here. So although I've done my civil engineering, I did my master's in environmental planning, and that's when I actually got introduced to mapping. The first map I probably created was of mangroves in the Thane Creek in Mumbai. And when I looked at different decades of these mangroves, I realized the mangroves were actually breathing naturally. You know, they were growing every decade and then they were coming back every decade. That actually made me start loving this whole technology of remote sensing and GIS. Following that, I worked with the forest department. That's when I got introduced to the wonderful uh, marine ecology, and we did a publication on corals. And since then, I've been working independently, and I've been working with consultancies doing environmental impact assessments, not the regulatory type, but the non-regulatory type, where where you have wind farms and solar renewable energy projects, basically, which requires some sort of a microsite being done. And so I sort of started specializing in creating these maps which would help these companies to actually site each and every turbine such that it does not disturb, say, neighboring settlements, or it's at enough distance from, say, key biodiversity areas or important bird and bat diversity areas. So that actually honed my skills. That's how I honed my skills in GIS and remote sensing. Since 2018, I've been freelancing, and I've been specializing in these GIS-based habitat assessments and biodiversity surveys, and at the same time conducting trainings in GIS remote sensing using all open source tools like QGIS, and more recently Google Earth Engine, which is an excellent platform for doing remote sensing. So with that, I'll start off with my presentation. The most basic thing, I think most of you must be aware what a geographical information system is, because we roam with this system in our hands when we use our smartphones. Each of us uses Google Maps. Each of us uses Google Maps to basically find out where the best biryani can be found, or where you can go for cycling, or which is the best location, meet your friends. So we know how to use a map, and it's nothing. Using any map is like using a GIS system. So it basically allows you to capture, store, and manipulate any kind of information, analyze data, and of course visualize it. But what's at the core of a GIS system is probably the remote sensing data that feeds it information. Not only so, remote sensing is often described as an art, in addition to being a science of acquiring information. It's very similar to what you do with a camera, right? But the major difference is the instruments that are fitted on these satellites. So these very sophisticated instruments can read different wavelengths of light or energy, and they can measure these wavelengths way beyond the visible spectrum. So if you look at this small area is the visible spectrum, what is visible to human eyes, and these sensors actually allow you to measure and capture light beyond this visible spectrum. Using this information, you can actually separate the type of, say, land cover that you have on the surface. So each of these land cover types will have a different kind of uh, say, a wavelength of light that it selectively reflects or absorbs. And that's what we make use of in finding out, say, whether a particular vegetation is weak or is less healthy, and whether it is healthy. So you can actually use this information to derive such results. Now, based on the type of satellite that is there, different instruments are being fitted on these satellites, and each of these instruments have certain different functionality. So you can see here, this is an example of three very popular satellite-based information that we use. One is the Sentinel-2, which is deployed by the European Space Agency. The other is the Landsat 7, Landsat 8, which is deployed by NASA. With the Landsat data set made freely available, it has become it is like very easy to actually tap into this remotely sensed data. And here you can see at how these different products vary with respect to the part of the spectrum that each of these products carry, and this can be then used for the different studies that we do. Now, when we talk about ecological restoration, probably the very first thing that comes to mind is developing a baseline, or say a creating historical information of what actually existed in that location or what needs to be recreated. So probably when we look at the applications of GIS remote sensing, something that comes at the top is developing the baseline. Then you have mapping of sensitive receptors. So like I said, the Landsat legacy data sets allow us to go back to up to 1980s, and we can look at what water bodies existed earlier, whether any protected areas, if they are protected, how the transition in those protected areas has happened. Are there any important biodiversity areas? So such sensitive receptors can be mapped on a GIS system. Then, of course, you can map the triggers that might cause a change in the landscape, or that are causing a change in landscape. Like you can map roads or any kind of other linear infrastructure. Finally, you can map the areas for restoration, and more importantly, you can plan as in a phase-wise manner which activities need to be taken up for your restoration effort and where these need to be taken up. So that phase-wise planning is possible using these tools like GIS and remote sensing. Other than that, of course, one of the most important things probably would be decision making. So visualizing and simplifying things for decision makers, so that every decision, every say intervention does not involve a lengthy and expensive field visit. So so these kind of systems, like a decision support system, can be created using GIS and remote sensing tools. So these are the basic I can say applications that are there for GIS and remote sensing and ecological restoration. I'll discuss few of the examples from projects that I have taken up, and some research that I've come across. So when we talk about developing a baseline, the most obvious thing that comes to mind is topography and say land cover. And then what follows that is probably the change in topography and land cover. So these are the most important aspects that you need to look at probably when we talk about a baseline on a larger scale. Of course, when we go down to a more detailed level, you need to look at the most important thing, the diversity. So when I was doing this study in the Thane Creek, I realized that most of these mangrove areas had a single species on the edge. All of it was Avicennia marina. And when you look at the older records, you find at least 5 to 6 species that could easily be found along this creek. But over the years, the diversity had changed. There had been a lot of siltation because of a lot of construction activity happening on either side of the creek. So there was a lot of siltation. The creek was actually narrowing down. And as it narrowed down at the edges, the most sturdiest of the species, which is Avicennia marina, started recruiting, and all the other species started taking a backseat and slowly started disappearing. So it's really important to understand the context in which you are actually the imagery that you're getting, and it's extremely important to also know the history of the area, and of course look go on field and check and review whether the results that you're getting using this GIS and remote sensing imagery is matching actually on ground or not. This is an example of how this is a small village in Kerala where I looked at an image from 1995. That was the oldest image I could find in Landsat, and how the the uh, the houses. There were a few houses here and there. Other than that, there was no development. But as you move on to 2021, you can see how the built-up area has shot up, and most of the agricultural land has actually transferred on to becoming a mixed crop plantation. When we discuss these maps with people on field, they also gave more information with respect to what how the change had happened. A lot of places the paddy cultivation had stopped, and they had moved on to say larger plantations. So these kind of things probably won't come up when you're doing remote sensing with just looking at the satellite imaging. So it's extremely important to go on field and collect information. Then, of course, you have mapping of sensitive receptors. So these are just examples of some of these receptors that we can easily map using open source data, using Google Earth imagery, and doing field visits, and of course using elevation data that's freely available online. So here I've mapped water bodies, stream network. On this map, there are reserve forests and wildlife sanctuaries. So these can also help you find out what all already exist in the landscape, and probably you can concentrate on areas which are not already protected, and also look at how the protected areas are undergoing a change. Then, of course, mapping triggers is extremely important. Uh, so there are a lot of open source tools and a lot of open source information that's already available. So this is an example of, say, the existing roads, national highways, and railway lines. On the other hand, you have also information like location of transmission lines, location of the wind turbine generators that are there. This type of location can be accessed using the open source map, the OSM database, and these triggers can be mapped for your landscape. Uh, when we generally talk about ecological restoration, often sometimes we miss out the marine part, and these kind of events like oil spills are extremely important, and they make you realize how fragile the marine ecosystem is. So here also for fighting such incidents, satellite imagery can be of real help. So this is an example of how a particular type of imagery called the synthetic aperture radar imagery. So this is very different from the normal optical imagery that we see. So for example, the one that we see on Google Earth is basically a combination of different bands of optical imagery. The synthetic aperture radar is like it's basically a radar system where it has got its own energy source. It's like a continuous ping that happens. It sends an energy signal from the satellite, which hits the surface and is reflected back and captured back again by the satellite sensor. So the best part about satellite, these type of this type of say uh, technique is that this can be accessed in any kind of weather. So I'll just maybe here you can see one example of how I've shown the same example. I've tried to show this of how the satellite aperture radar imagery can be used to map a oil spill. So here, when you see the darker patches here, this is actually an oil spill that has happened due to a ship here. Okay, and using a simple code for which I'll just pause sharing for a moment and share my screen again. Here you can see on one hand you have the optical imagery, and you can see the amount of cloud cover that is there. This is a part of this is off the coast of Mauritius. Okay, and on the right hand side, when I just flip it, you'll find a small twinkling thing over here. This is basically the ship where the oil spill actually happened. And this was a couple of days after the oil spill, and you can see the oil slick moving across the coastline and how it's affecting the entire coastline. So that's how it's a different kind of using a different type of satellite imagery, you can actually get more information. And this is all possible by just using a small code. So if I just drag down this window, you will see a part of the code that I have created just to map this kind of an oil slick using the SAR data. So this kind of remote sensing data can help you quickly mobilize people on site, mobilize your teams, and help decision makers make quick decisions. Because using these platforms now, imagery is available within a few hours, say about 5 or 6 hours, you are able to actually see what's happening. This is another example of using a drone and using, say, a remote sensing imagery in combination. So in Australia, they did this study to identify and map corals. And if you're not aware, then in a lot of places, especially in the tropics, there are a lot of cases of coral bleaching that's happening, and it's from the reasons for that are, say, our climate, our Earth warming up too much. There are these huge, large-scale coral bleaches that can be even seen from space, and so they came up with this innovative method in which they use a very sophisticated sensor, which is called a multispectral instrument. They fitted it on a drone and they captured patches. As you can see here, they captured small parts of the coral areas, the ecosystem, and then they were able to basically map where the live coral was located, where there was rock and sand, etc., etc. And they could also find out how much of healthy coral was actually present. And using this information, then you can actually extrapolate it for larger areas. So this is again becomes a very rapid method in which you can judge the say where exactly a restoration effort needs to be concentrated. I'll spend a little longer on this small slide because this is something. This was a very interesting work that I did for Junglescapes, where they were actually using this cut root stop method for removing the lantana camera, which you must be aware is an extremely invasive say species, and it's all over it's found everywhere in the Indian subcontinent. And here, this is a part of a small range that we did a mapping for. We tried to map the locations of this species in this particular range, and we came out with very interesting findings. What was more interesting was the interactions with the whole team of Junglescapes as to how do you identify lantana camera from space. So those things were very interesting, and since we were in lockdown at that time, I personally could not visit those locations, but the Junglescapes team was on site, and they were able to go on site and collect information on ground, and they then used to tell me what locations there was, say, a denser patches of lantana where there was less density of lantana, and accordingly, after getting this kind of sample data from them, he mapped the locations of where the lantana camera say species is distributed across the range. Using this map, then we also actually created a grid with each of these say squares telling you how much of effort might be required to actually say restore the area, and this then hopefully they used for planning their how where the restoration efforts can be targeted first. So when we talk about GIS and processing, is basically the documentation that's important. So you can use these. There are different type of tools that you can use for basically data collection, either primary or secondary. Then analyzing this data and then interpreting it, and then of course at the end visualizing it. So I'll just quickly summarize some of the examples so that these are some of the resources that you can use in your own work. Okay, to start with data collection methods, this is my go-to software if you're using Android. Then Locus Maps is the go-to software where you can actually load all your shape files or GPS data and visualize it on, say, Google Earth Maps or any kind of background map that you have. In addition to that, you can also map your locations. You can add, say, photographs which of your locations onto the map itself. It's extremely dynamic and very fast to use. So I often use this on my field visits. And if you're up for it, then you can read a small article of how I use this software to actually find my lost phone on field. So this actually software helps you go beyond GPS devices. Often people don't want to invest in, say, expensive GPS devices. Then you can easily use the software on your phone and access different base maps, and you just transfer your results on GPS locations onto the application itself. Uh, Apart from, say, the actual primary data that you're collecting, there is a huge amount of data information available to you through remotely sensed data. One example is the demo I showed you on the SAR imagery. In similar fashion, there are different land use, land cover maps that have been created by the European Space Agency, like a global land cover that's easily accessible. So you don't need to actually go through the entire process of downloading satellite imagery, analyzing it, and then coming out, going on field and checking those kind of things. You will have a land use with you. You just need to go on field and check whether the land use is accurate or not, and use it directly. So a lot of information is available through a platform called Google Earth Engine. It's free for researchers and not profits. They also have now a commercial product in the offering, but it's an excellent software, quite easy to use once you get a little bit hang of, say, if you already know Python or R, you can easily use this. Otherwise, you need to know a little bit of JavaScript, a part of JavaScript to actually make these maps, but a lot of information and tutorials are available online. For data analysis and interpretation, my go-to software is QGIS, which is open source, it's free, and it's extremely feature-rich. In fact, I love the visualizations that you can get from the software. It's much better than ArcGIS, and I've helped a couple of companies actually transfer all their workflows from ArcGIS to QGIS, which was really fun. So these are some of the maps that I've created using QGIS. Here you can see on the top, this is a map of the receptors, sensitive receptors, and certain triggers that are overlaid. So here you can see I can overlay, say, noise levels in these areas and see which of the sensitive receptors might be affected because of a certain project that's coming up. Here below, you can see maps of, say, sensitive areas or sensitive bird locations that we surveyed on field, and, say, bat locations that we surveyed on field, and then we transferred onto GIS system and extrapolated the data to check which locations are sort of no-go areas based on the diversity that is found there. So this kind of data analysis and interpretation is now very easily doable in free and open source software. And of course, with R and Python programming, it's become even more easy. Modeling is an extremely important thing that's coming up now, where you can use, say, global climatic data to actually find out whether a species can, how a species, the distribution of a particular species may be affected due to climatic or land cover or any other topographical factors. So this is an example, a quick example of how I tried to model the the occurrence of this species in Nicobar Islands, and I used this algorithm called Maxent. I used data from the Global Biodiversity Information Facility, where they had uploaded the locations of occurrence of these species, and I used this online this platform which allows you to upload this data, use different kind of algorithms which are there, and make your own settings for the algorithms and generate outputs like these. So it's extremely powerful. You can have a look at this to actually help you with different kind of species distribution, and especially for invasive species, this becomes an extremely powerful platform where you can actually model for the entire, for large landscapes, you can model the distribution of invasive species. Yeah, again, data visualization extremely important. So when you look at a map like this, there's a lot of information that you get in this. First, you know where your actual known locations are, so you know where your entry gate to the sanctuary is, you know where your forest office is. That's one thing, but you also know, say, which, according to forest department, which are the areas that are fire affected. So the forest department has created a map of which are the fire affected areas. You can overlay that map on this and check whether how the lantana in those areas is, say, behaving, how it is, say, coming back, or is the native vegetation able to supersede it, etc., etc. So this becomes a great tool where you have a single map, but it's giving a lot of different kinds of information. So it's extremely important to, say, design the map and make it legible and readable and easy to understand. So data visualization, again, both these maps are created using the QGIS software. Apart from QGIS, there are, where people are not so well versed with using GIS software. I think Google Earth is an extremely powerful tool, and this madness of, say, mapping and looking at old satellite images started with Google Earth when they started giving out, adding these old images to Google Earth. Here, this is an example of how the same maps that we are seeing on a proper GIS system can be again visualized. The shapefiles can be added onto Google Earth. You can even add these small legends in the form of these legends to your map. So if you're sending it across to your clients, they can easily visualize what you're talking about rather than just seeing at a small cutout of a map in a report. So that's one way of visualizing using Google Earth. And then this is an example of you can use somewhat of a dynamic presentation using a GIF image, where you have this is an example of Pune, where I have mapped the pollution levels at I think 4 different locations, and I've just animated this again using QGIS to see where the pollution is exceeding beyond the AQI category as per the CPC. So that's it.
There are a few questions in the chat box. So yeah, few of them will come eventually. Yeah, so there is this question from Mr. Akshay, how have you collected the baseline historical data? Does charges apply for these data?
Okay. Thanks, Akshay, for the question. So, depending on the scale of the information that you are looking at, it will depend. Like, so if you have a very high resolution image that you want to download, say 4 meter resolution or a 3 meter resolution, then it might not be available for free. But let me also inform you, right now the company called Planet Imagery has uh, made most of these high resolution images available for, say, the global south, which is India and some of these South America and those countries. So you can actually also get high resolution satellite imagery for few years, till few years, I think from 2015 onwards. But otherwise, a lot of this information is available online through different resources like the Forest Department websites, or say certain portals like OpenStreetMaps, where there are people continuously creating maps and uploading it onto the data set. So you can download it for free also. With respect to historical imagery, it is a challenge, but what you can always get is scan old maps that are available to you. You can use topo sheets which have anyway not been updated for a while, so you can easily check the older topo sheets, and now scan topo sheets of 50,000 1:50,000 scale are available online, so you can download those and map using those also.
I have one question.
Yeah.
Compared to ArcGIS, how convenient is QGIS, and in what terms it is more I would say better than ArcGIS, which you were just talking about?
So the most important thing is that it's free, it's open source. Uh, the second important thing is that it has a great, and it's got a huge community that's backing the software. So it's continuously improving, and it has a lot of these things called plugins, which extends its functionality. With every plugin, you get more extended functionality, and I found that a lot of processes that I used to do on ArcGIS actually are a little bit easier for me when I'm doing it in QGIS. Also, the visualization I find is much more easier and intuitive. But then again, I have stopped using ArcGIS for, say, from 2015. So I've sort of started liking QGIS so much that I actually stopped using ArcGIS. And it's not very difficult to switch because essentially all GIS softwares are very similar.
Yeah, but then yeah, it is always said, or what I know is ArcGIS is more uh, QGIS. You cannot. I mean, it's more the more reliable source is ArcGIS compared to QGIS. QGIS being
So,
open software. What your
right.
views on that?
So the thing is that at the end, ArcGIS uses the same algorithms that are used by QGIS, and they also stick to the same standards that QGIS has. With respect to stability, yes, it takes a while. Sometimes some of the plugins are not designed, as per your system. But the most important part with QGIS is that you can have multiple versions of QGIS. So that's what I do. I use multiple versions of QGIS, install it side by side, and each of them gives you better functionality. With ArcGIS, it takes a lot of resources of your computer as compared to QGIS. So that's another thing that I've noticed. It takes a lot of space also. It uses more resources also. So I found that part also much more better in terms of using QGIS. The other thing is it's also possible to use it on Mac. So if you have different systems, you have Linux, Mac, and say Windows, then you can't use ArcGIS on Mac or Linux, but you can definitely use QGIS on all of these systems.
Yeah. Okay. Thank you. There is one question from Shivram Somsan Sundaram. Does remote sensing record layers in vegetation? Example, ground cover, middle cover, and upper canopy cover.
Okay, so like I said, depending on the instrument that you're using, uh, you can actually see all of this also. So generally, when we look at one particular image, for example, Landsat. Now, Landsat is generally looking at whatever is visible from the top. Okay, it's very simple. It's only looking at what is on the top. But if you start mixing it with other type of information like say lidar. So lidar, I don't know if someone has the latest iPhone, you might be having a lidar sensor in along with your camera. So lidar is nothing but it's a laser based technology where the instrument shoots a small, very tiny laser point at whatever object that you're looking at, and then when the energy comes back, it records the location, shape, size, position, etc., etc. And so this becomes a more sophisticated exercise, but then you are able to create like a three-dimensional model of whatever you are surveying. And then you can mix it with the general optical imagery. You can mix this lidar and get this different stories of this vegetation that you have, ground cover, middle story, etc. Even the example that I gave you where we mapped the lantana, the biggest challenge was that how do you map where you have lantana in the understory, where you have vegetation, native vegetation on the top, it's completely covering, and you have lantana at the bottom. So that was a bit tricky. That's a bit tricky when you're relying only on optical data. But there are a lot of new imageries that are coming up which are making it possible. Of course, technologies like LiDAR are extremely expensive. If you want to do it for a larger scale, then it's very difficult. So what people do is they sort of capture samples of the data and then they use the freely available or say large scale imagery to extrapolate the information.
Yeah, there is another question from Mr. Shivram. In terms of topography mapping, especially in open spaces in urban areas, generally a total station survey manages to record 1 meter contour interval recording. The change topography as well in terms of built information. In terms of GIS, is this accuracy available?
Okay, so when you talk about, say, if you talk about GIS, then this exercise of using a total station on ground is also sort of this it's a form of collecting information and feeding into it. So once you collect this information, the next process would be just uploading all this information into a GIS system. So you'll get the same accuracy that you're getting on ground. I hope that clears the question.
Yeah. Aishwarya is asking, what all simulations can be done on QGIS? Can we do a flood simulation in QGIS?
Yeah, so flood, it's possible to do a flood simulation. It's a fairly simple exercise, and you all you need is elevation data, and you need the levels, the flood levels, and you can easily do a flood simulation. There are also specialized plugins that can be used to do these, which make doing these kind of simulations very easy. So you can definitely explore that.
Yeah, there is one question. Can one use drone data with GIS?
So drone data is pretty resource heavy. It's like, say, if you're shooting with a 2 megapixel camera, compare that to shooting with say 100 megapixel camera. So it's not that simplistic. But then when you're using drone data, the information, the volume of information is huge. So to actually organize and analyze that information, process that information, the resources required are huge. So depending on how big an area you have surveyed using a drone, you actually might not be able to use your laptop or a normal desktop to actually easily or quickly say process that information. You might have to like keep your computer running for a couple of days to actually get that data processed. It's possible, but it's it's very resource hungry. So for that, you have a lot of these online platforms that have come up where you upload your drone data onto their servers, and they help you process the data. But essentially, what they're doing is adding locations, stitching your images that the drone has captured. The drone is essentially going to capture an image or a video. This online software is going to digest all that information. It's going to digest all the information that the drone has collected with respect to the location, etc., and any other information that you have collected, and it is going to create a three-dimensional model, okay, a digital model, and that is nothing but a 3D map. So that can easily be then downloaded onto any kind of a GIS software on a system which has enough resources to visualize and analyze that data.
Yeah, thank you, Mr. Rohit. I think many questions have been answered, and thank you very much for this informative session. And it was very well presented.